Okay, what happening? Oh, so if the node is root, parent is null for sure. If the node is inner node, if it is subchildren, right, that means have to count the node having PID equal to here, right? Okay. So how do you do if else in MySQL? So first, right, we have to select ID from tree, right? The type here we need to figure out if the PID is null, right? Then we return. How do we do that in MySQL? Case when case when we do case when PID equal null, right? Then root. Let's see first if this works. Other and so we got the root. Can we do so first we gotta do the select ID count of children, right? ID from 3 select ID count star child count 3 and we count the node. Okay, so let's see, select ID count star and 3 so this is correct. So let's say 1 it should be 0, 2 should be 2, so we have to merge with the ourselves. So where p.id equal PID, right? P.PID, which is to say we need to do some kind of subquery, right? So when we select like 2, right, we have to join with the same thing where PID equal that one. So let's say we come across 2, we want to find anything that have a PID equal to, right? So how do we materialize that in SQL? Do we join with ourselves? So for sure you have to do some kind of count, right? From the where PID equal to, so basically can we do this? ID PI key to tree.id, right? That sounds like we can join ourselves. So select whatever here, right? From tree. SQL self join. Okay, so we can do left join. Okay, we can do left join employee from employee left join employee. Okay, from tree choice on tree dot this is the tree. Let's call this P. Let's try tree C on. Basically we have so what we found is two has 4 5 here, right? So we want to do select ID child count, want to group by p dot id. P. Oh, count. So 2 have 2, 3 have 1. That sounds wrong. Form have 1, right? Let's say n. Let's just print out the result and see. Star. And let's say p.id equals to 2. Why does it appear to everyone? Oh, 3 and 4 is 3 4 5 have the same, and p dot c dot. So what happened here is when we join with ourselves, when I ask, let's say 2, parent ID is 1 here, we see it mapped with the same table for 2 because the condition is these two equal this two, right? So for and find, we couldn't find the ID that mapped to that, and we condition would be not equal to null. Right, so now we have what? What is going on? What does this give? Equal, not equal. Is not null. Because what is wrong here? So first though, bro, why does the output, can I do 2? Okay. So first I want to know parent child, right? Where parent child dot parent ID go to parent.id. Okay, so what does this give? So 1 it found 2 nodes, 2, 3, good. 2 it found 2 nodes, 4, 5. Okay, so basically we can do ID count, right? So this will be child count. Okay. What? Where is it? This is star, right? So star gave us this row right here. Can we group by p.id. Oh, p.id found star, right? So we're gonna group by 1 and 2, right? Okay. So this has 2 nodes. This has 2 nodes, right? So we want to select first. So if it is root, then so this entire thing here is the table from this table here. Right, we want to select ID the type. We need to say case when ID we have to get from tree, and then also from this. And so first do case when so okay, so hold on. Can we do select ID oh, this is another table. Oh, okay, where tree dot ID go t dot ID. Right, so so when we merge with this table, can we do, hold on, can we left join and still here? Left. So we saying SQL joy visualization, right? So in the case of 3, 4, 5 here, it found 2, right? So 1, 2, right? found one too because basically this query basically found the parents. For the one that it couldn't find itself, so for example 1 we found 2, 2 we found these, 3 do we found any 3? We don't find any 3, so we want a left join because we want to show that row, right? Got all the record in the left table regardless if any of those records have a match in the right table. This is left join, right? So what is that? From table A, left join table B. From table A, left join. So let's start back to beginning. On basically, let's not do this. Okay, now we're back to this. So 1 it found 2, right? 2 it found this, 3 it found this, right? So what we need to know, we need to say is we're gonna group by this first, okay? Can we infer something from this? Right? So when we find 3, is anybody with 3? We have parent IDs 1, but I don't have these, right? So this means that this is the this case right here is the leaf node, right? So basically we want to select p.id. We want to group by id c.id, right? Group by p dot id. Just complain. No. Right, okay. So we want to count. Do we want to count though? Count star. But if we count star, we lost the information, right? Right, so we know that this count us the children, but this row actually has some information here that we want to understand, right? Who is sending me message? MySQL is so struggling. So basically we want to count this correctly. Should be 0 here, right? So let's select star from now. Right, so we want to mark the case that if can we do MySQL count if else? They say I can do count here. What is the example? So I would do p.id sum if go. Okay, okay. So I do sum if the children.id equal to null, then is null. MySQL if is null. Okay, so can I do case? I have to do this. Case when child.id is null, then I return 0. Otherwise I count star. Child count, right? Can I do that? Oh, group by p.id. Okay, so this is the leaf node for sure. So to know the root, we also need another case for if the one here has the okay. So can we do when p.pid is null, then basically we do -1 for the root, right? There we go. So now all we gotta do is, oh, we actually can just do this. We can just do it. This is, then root, right? Right, inner. Oh, this is inner here. Right? Inner here. Otherwise, this is leaf node. Right? Oh, type. Something like that. Ooh, okay, that should be it. Let's see. Okay. So the struggle I have with this is basically cell merge, sometimes confusing, and I am trying to do multiple things as one. Well, let joy suffice. Okay, so now we will commit this to our GitHub. Then we look at some of the article, and then we write our Substack. Okay. So let me commit this into my VS Code. So what did we do today? We did maximum product of word length. That was yesterday. So now let me add the text here saying commit to GitHub. Okay. Alright, ni get some water. First we gotta look at the daily. Oh, this is new. Medium. Maximum product word length. So it's okay. Okay. So we have two solutions. Maximum. Okay. So turns out the solution for the original solution just need cache for this problem. Okay, so I'm typing right. So this is the first solution. Runtime here is what's the node here? So hold on. When I submitted with this, I submitted with oh, this is the solution using the this 4000 whatever here. Make no sense because it's longer than is slower than the solution for the array frequency map. Which we have to write about. For okay, so this is actually the bitmap, right? So the solution after we cache them using is actually better, right? Which don't understand because it's actually allocate the array, right? So how is the array better than the bit operation, right? But that will do for now. Right. Very strange, but that's fine. Very strange indeed. Okay. And what is the similar problem? Python. Okay. Oh, I want to store. What did we modify here? We did yeah, we did. Okay, so that's one problem we did. Second problem we did early in the morning. We did reconstruct. Oh wait, longest absolute file. Submission accepted. Alright, just simple parsing and basically getting the expand the directory or go back the directory correctly. This is on time. Whoa, what happened? Time 3 milliseconds beat. 37. Dot. Okay, now we do run the Python to check if the test is passing. What? Okay. Okay. Wait, hold on. Oh. Okay, that's the second problem. This one we did in the morning. Lot of bookkeeping. Reconstruct. Original. Right. A lot of trial and error here. Time for this is 22 milliseconds faster than memory is 1986 faster than 74. do this daily. You want. Submit. Okay, and then finally the tree node that we just did. Tree node. What no more memory usage. Okay. This is Fukushima. Okay. Daily. So the suggestion here is
told me that I always had to be good, but being good always through problems is true.
Okay, get pushed. Ah. Ah. Yeah.
I'm crazy, but I'm around, baby, it's true. Yeah. What if I'm not good? What if I'm not good? If you never love me back, What if I'm not good? What if I'm not good? If you never love me back, What if I'm not good? What if I'm not good? If you never love me back,
Okay, so now we need to read some articles.
if you never love me back.
Reading article in React. We have 15 minutes. Then we have to start writing the article. All these.
What if I'm not good? What if I'm not good? If you never love me back, What if I'm not good? What if I'm not good? If you never love me back, What if I'm not good? What if I'm not good? If you never love me back, What if I'm not good? What if I'm not good? If you never love me back. They told me that I always had to be good, but being good always be problems is true. So I learn it, and now I know I don't wanna play God. Maybe I'm crazy, but I'm around, baby, it's true. Yeah.
Okay, so I'm gonna go restroom break real quick. Restroom, and I'll be right back. Okay, why does Toyota have a need for a game engine? Why is that the case? Be right back from the restroom.
Should've known better than to trust in love. It's like this whole world keeps on messing it up. Yeah. I thought that I could do better if I just believed. I'm thinking back to when you were in the sweater that you got from me. It's so complicated. Why is this suffocating? I felt elevated
Okay.
when you used to lay with me.
Okay, so let's see if we can get the videos and play them. Oh, it does work. Okay.
Well, that is a yes. Well, thank you so much for coming. I know this is the last talk of this day, or like at least within this dev room. So I imagine some of you might be quite tired. So just to get our spirits up for the last time today, can we get a big yay from the audience?
Yeah.
There we go. That's what we're looking for. Well, with this said, there might be a small surprise for some of you who might have expected a slightly different title. But today we're here to talk about Fluorite, the console-grade game engine in Flutter. I'm here on behalf of Toyota Connected,
Hold on.
presenting this.
Why does it completely white over here? Does it occlude something? Wait, hold on. The video's only. Yeah, that should do it. Okay. So now we play.
Presenting this talk. My name is Jamie Kerber. I'm the consulting senior engineer at Very Good Ventures and the lead engineer on the Fluoride project. This talk has been prepared in coordination with Joel Winarska, the principal engineer 3 at Toyota Connected North America and the lead and founder of the Fluoride project. He's very sad he couldn't be here with us today, so he asked me to share a short video message for you all.
Welcome, and thank you for attending our talk. My name is Joel Winarska.
Can you hear that?
I work for Toyota Connected North America, and I'm responsible for Flutter Innovations at Toyota. You may have noticed.
Oh.
Unfortunately, I am not able to attend. Hello, welcome.
It's
1, 2, 1.
I think it maybe. Yeah, it's already maxed out.
And thank you for attending our talk. My name is Joel Winarska.
No, it's not gonna work. Sorry.
Wait, maybe this.
I am responsible for embedded
Oh,
Flutter.
there we go. We did it. Oop.
Hello, welcome, and thank you for attending our talk. My name is Joel Winarska. I work for Toyota Connected North America, and I am responsible for embedded Flutter innovations at Toyota. You may have noticed I changed the name of the talk. Unfortunately, I am not able to attend FOSDEM this year. Instead of canceling, I made the decision to share another innovation we are working on. Let me introduce Jamie Kerber, my colleague from Sweden. Jamie, take it away.
Well, thank you very much, Joel, for this wonderful introduction. With this said, let's just get into it. So, where are we today? What is the Toyota Connected's state of Flutter on embedded platforms at this point in time? Well, Toyota is responsible for the development of the IVI home screen, which is the Flutter embedder for embedded targets running Linux with a Wayland interface, which is a huge part of the MetaFlutter project on Yocto Linux, which enables all kinds of embedded and automotive Linux solutions.
Okay, so
As a real-life production use case, we have the Toyota RAV4 2026 model, which has been announced very recently, and it just so happens to be running this precise stack. So that's production grade for you. We're all very excited for some of you to try this product very soon. If not, well, perhaps next time. The downside of that solution, however, is that just like most other Flutter applications, it only supports 2D static interfaces, which kind of limits the expressibility when it comes to designing UI and UX interfaces. So we were kind of thinking, how do we want to solve this problem? And we realized that the next obvious step for digital cockpit innovation are game engines. So, sounds great, right? Like just like take a big old game engine, slap it in and see what happens, right? There's a lot of very fun use cases for it. For example, let's say that in your new product, you might want to integrate an interactive user manual, which might show, for example, how to use certain features of the vehicle in a step-by-step basis, providing very clear instructions using 3D illustrations to your users. Another one could be hardware state visualization. So let's say that you can see on your screen a 3D model of the vehicle you find yourself in, and let's say that you might want to notice whenever one of the lights is broken. With this, we would be able to pinpoint exactly which one it is, making it very easy to enable, for example, self-service scenarios, pointing the user exactly to where that light bulb is, and again, tying back to the previous step-by-step tutorial feature, how to take care of such a use case. Another one is environmental mapping. Let's say that you find yourself in a particularly tricky environment with a lot of obstacles and you want to be able to avoid them swiftly. With this, we're able to, if we have a 3D mapping available of the outside environment, project it on your screen inside, allowing you to maneuver more accurately in avoiding those obstacles. On top of that, we can enable way more natural controls for, let's say, things such as like heating or like wipers or any kind of functionality in a vehicle by providing 3D objects that look similar to their real-life counterpart, making it a way more intuitive experience to control such settings. Last but not least, there are already a number of other manufacturers on the market that do provide similar solutions. Thanks to Fluorite integrated in Flutter, we will be able to enable all of you to compete on that market by providing equal, if not even better solutions. However, please note that all of the above is just technical speculation on my part and does not in any way whatsoever reflect the roadmap of any existing product. With this said, what would be the challenges of integrating a game engine in a Flutter application in an embedded scenario? Well, we actually tried that, and it turns out that all of the existing game engines that we tried were not adequate for this type of solution. Based on our internal investigation, the main problems with Unity and or Unreal were that they are closed source software. They require proprietary blobs to be shipped as part of the Linux distribution, which unfortunately means that we would lose on Yocto compatibility, which is a massive chunk of our use cases. Not only that, but whenever you integrate a native view of this type in a Flutter application, for every single one of them, you have to spin up a separate instance of the entire engine, which is very, very heavy on resources, and in our experiments has led to very low frame rate and poor performance. On top of that, count hefty licensing fees that might go as high as multiple millions of dollars per year. That was a bit of a non-starter, so we tried with something more promising, a real up and riser, that being Godot, an open source game engine that has lately seen quite a bit of adoption. In that case, when testing on a Raspberry Pi 5, which is one of the more groundbreaking embedded platforms, we noticed an unfortunately long startup time of 20 seconds and above. That sadly wasn't acceptable, but in further testing we found it was also resource heavy in a similar way to Unity and Unreal, at least for our use cases. So we tried to go with something a bit closer to the Flutter core. Using the Impeller renderer and the Flutter GPU package, one should be able to integrate some sort of like 3D visualization in your Flutter app. However, we found that while it is stable on iOS, it unfortunately is unstable on Android and flat out unavailable on Linux, macOS, and Windows. So with not being able to run it on Linux, that's another solution that we have found unavailable to us. And also to that you have to count the immature API of that solution that is in constant improvement, but was just not moving fast enough for us. So what is the solution that we came up with? Let's start from the technology we already had on hand. First and foremost, we have Flutter running on embedded platforms, thanks to the IVI home screen and MetaFlutter projects. Second, we're working on a Flutter SDL3 embedder, which enables cross-platform I/O across multiple types of embedded devices and platforms, as well as operating systems. To that, add Google's Filament 3D rendering engine, which allows one to render really high-quality 3D environments using physically based rendering and anything that entails. So how do we put those three together? We get Fluorite. Fluorite is a game engine fully integrated in Flutter because it is a package that you integrate in your existing Flutter applications, meaning that you can greatly reduce the complexity of merging a game application and a Flutter UI application, since you code both in the same language using Dart as well as any other tooling that comes with Flutter. Thanks to this, you can share code between UI and game logic. This is because Fluorite View is just another Flutter widget that you can integrate anywhere in your applications. This way it benefits from the Flutter layout system. You can place multiple of them at the same time for multi-view scenarios. And this also means that they can share state between each other. You can have game objects and UI widgets being part of the same context, can use any of the existing Flutter solutions for state management, such as Provider, RiverPod, or Block, to talk to each other in real time. Let's go through a short showcase of features that we have already developed for Fluorite. Well, the main one is the high-performance ECS core. In order to stay within the realm of the well-known style of game engine APIs, we decided to base everything on top of our own entity component system. With this, we implemented the main core in C++, which allows us to drive really minute optimizations for low-end and embedded hardware by controlling memory and processing in a very, very tightly integrated way. However, all of this is presented to you, the developer, as a very clean and high-level Dart API, which very closely mimics the same APIs you might already know and love from other game engines such as Unity, Unreal, Godot, and many others. As a part of that, we provide a hierarchical scene graph, just like in all of those other game engines, allowing you to provide complex and nested objects in your scenes. This means that all of the knowledge and skills that you have acquired while developing for all those other game engines is 100% transferable, plus and minus some API minutia. But here in this picture...
Wait, what do you mean by premium? Vortism? No, I don't have premium LeetCode.
You can see a working example taken from one of the applications you're going to see later in the presentation.
I might buy it.
It showcases a simple bouncing ball. So we have an ID, we have a name for it, and we have a list of components.
The one I've been doing so far is
you have a transform
free.
with position, scale, rotation. You have a collider, you have a model, a renderable, and a behavior script with such functions as onCreate, onUpdate frame, and similar. One feature we're particularly proud of are the model-defined touch trigger zones. This feature enables your 3D artists and your game developers to work in parallel by letting the artist define which areas of the model are clickable and for the developer to later connect that event to some sort of interaction with your application. In this case, you can see the wheel being tapped and that increasing the tire pressure. At the same time, though, you can see that there is a synchronization between the game state and the Flutter application because you can change the sliders and that regulates the size of the various tire pressure indicators on the said car. What you're seeing right here is an application that we have developed in Fluorite. It showcases a simple 3D scene with a lot of high-quality assets, as well as the aforementioned model-defined touch trigger zones. And of course, we want to present console-grade 3D rendering. Google's Filament enable us to provide high-quality workflows, which are optimized for embedded platforms, but also allow you to use a variety of high-quality, physically based assets and lighting systems.
Okay.
But of course, that is just one of the many use cases. Another thing we provide is a customizable shader and rendering pipeline, which can allow you to, to design any sort of more stylized performance in accordance with your designer's own vision. And of course, it wouldn't be Flutter if we didn't have hot reload. As you can see in this video, I'm simply typing a different value for like the orbit distance for the camera and pressing save. And in the matter of less than a fraction of a second, it's reloading the scene as we're looking at it, which is orders of magnitude faster than other solutions like Unity and Godot. With this, where is the Fluorite game engine going next? What does the roadmap look like? Well, the very next item on our agenda is implementing the Jolt physics integration, which would allow us to define any sort of realistic and deterministic interactions between game objects in our
is pretty cool.
simulated world. This will be available as just another component attached to your entities, probably called physics, which will allow you to define a variety of collider settings, either rigid or soft bodies, and many more. Next up, we're going to enable a higher amount of creative workflows. We're working on delivering CLI and GUI tooling to better support both designers and developers in mutually developing rich applications for all of your use cases. As of today, we already support many open formats. We have Blender compatibility, we support GLTF and GLB models, KTX, HDR, as well as other formats for textures, and the shaders are programmed using a superset of GLSL, which is the same shader language you might be using on most other platforms. All of this is supported out of the box. Thanks to this, you can very easily, in a matter of minutes, if not seconds, port assets from your existing game projects in those other engines. And of course, this wouldn't be an embedded automotive talk if we didn't mention full cross-platform
Okay,
support.
USDL3
Thanks
for
to
rendering.
Flutter SDL3, we'll have full support for embedded platforms, mainly Linux, which includes Yocto, mobile, on iOS and Android, desktop on all the major desktop OS systems, as well as game consoles. This is all thanks to SDL3 that not only provides us with all of the tooling necessary, but thanks to the platform agnostic nature of both Flutter and Filament, which has very easily allowed us to experiment with that and will help us in delivering those experiences to you in the near future. And of course, it would be kind of sad if we kept all of that to ourselves, which is why we're also going to release an SDL3 API in Dart, available as a package to include within your Fluorite applications. Well,
Is it open
but
source?
how do we get to all of those next steps? You know the
Boston, right?
saying, teamwork makes the dream work, which is why we are seeking collaboration with engineering teams. Mainly what we're looking after is the commitment of development resources to the Fluorite project for the purpose of establishing and delivering on a common roadmap as well as feature development for the purpose of this engine. There is a website available. Right now it has a very neat looking coming soon view, but in the next couple of days we're going to update it to include all of the key information you have seen in those slides. But with this said, oh, actually, I'm going to give you a couple seconds to connect with that QR code. Yes.
My question is about do you plan on integrating the accessibility
Right.
You mentioned small console for like automotive.
Right. Sorry? There we go.
Sorry, I didn't know I need the microphone. My question is about accessibility. You know, Flutter integrates nicely with native OS accessibility frameworks. What about the UI and stuff that is rendered natively? Will it also be possible to, for example, write my game components or like the 3D objects with like something like, you know, accessibility widget, and it will be exposed to someone who is, for example, blind?
Right. Yeah, we're still working on the API for that. However, it is something we are actively considering. We are fortunate enough that Flutter does have a rich accessibility API thanks to its semantic tree. So the plan would be something adjacent to incorporating a semantics node as part of the semantics subtree, which would be then provided by a Fluorite View widget.
So like when you click the accessibility, it will speak out where you are, right? Like you are accessing a menu, right? Whatever, right? To the left it is, to the right it is, I guess.
Right. This is the question section. Oh, no worries at all. So, Any more questions?
Thank you. Yeah, you mentioned cross-platform support across all the native platforms that are supported by Flutter today.
Sorry, could you a bit
Oh, yeah,
louder?
sorry. You mentioned that you are supporting all of the native platforms supported by Flutter today. I was wondering if you also explored using, say, WebAssembly and WebGPU, if it's possible at all to also make this available for Flutter web apps.
We have yet to consider like a broader range of those. Right now we're mainly focused on targeting just the latest versions of Windows, some of the Linux distributions, and macOS. But please do bring it up whenever we open the GitHub repository. We'll be happy to take a look at your issue.
Thank you.
Any more
Anyone else?
questions?
Anything at all?
Then I have one question. Do you render all the stuff on CPU or on GPU?
Oh no, it's fully GPU accelerated. We're using Vulkan to drive the Fluorite 3D renderer. So we basically get the full GPU acceleration of whatever platform you find yourself on.
Great, thank you.
Oh, I'm seeing one more question. Bring them on.
Last one. Do you, when you're building this infotainment system for the Etika car, do you have some UI testing process that tests that the feature you're building actually like works as intended?
Sorry, could you repeat and?
Do you use any UI testing solution? As in, when you are building this infotainment system for the car, how do you verify that this works? Do you do any UI testing? That's the question.
I don't think I can answer any of that. I'm mainly focusing on developing the software around it. What you're asking is probably under the responsibility of a different team. But again, I'll be happy to look into that a bit more later and see if I can provide you with an answer. But I'm sure that whatever we are working on will never be shipped into a real vehicle unless it passes Toyota's rigorous quality standards that are already being used in any of the current products.
One more?
Oh.
So, if this is available to port or will be available to port to different boards, is there, or like outside of a car, or maybe that's the car is like vehicles are the focus. I work with a lot of embedded systems in robotics. I do a lot of visualization. I'm wondering if there's any plan for like integrating sensor data, or to be able to read sensor data and like render that in Fluorite.
I mean,
because that would be kind of cool to be able to see like
Yeah.
point clouds, lidar images, things like that.
I mean, yeah, that's definitely a very cool use case scenario. And while I'm not sure whether we're going to experiment with that ourselves, it's definitely sort of the type of experience we want to enable. In terms of board compatibility, like what we're going to do in general is test it on a very small subset of target devices. However, in general, assuming we've done everything right, this should run basically on anything that runs Linux, supports certain hardware requirements, and has a version of Vulkan of 1.1 and above, if I have that correct. Right now we're definitely testing against Raspberry Pi 4, so like that's sort of like one of the devices we're looking at. Sorry, Raspberry Pi 5, my bad. There's probably some more, but that's the one I can definitely tell you about right now. Do we have time for any other questions?
That's
okay.
it.
All right. Thank you so much for coming. If you have any other questions about strategy and the general direction of the project, as well as collaboration, please email Joel Winarski@toyotaconnected.com. However, I'm available myself to answer any and all technical questions. So let me know. Thank you for coming.
Okay, so here's the site. pretty cool. I forgot about the music. It's the discussion. Filament. Yeah, not a lot of discussion, but it's pretty cool. Does it do Vulkan? Does. Okay, pretty cool. Let me get some water and we're gonna start writing our Substack. Actually, I have a drink. Have coconut water. Where's my Substack? Be this. That's what I'm writing right now. Okay. Let's see. uh, what? I'm gonna create a new post. Okay. So what we did is Okay, so now we have to change the text here too. Friday. Okay. Started off with a brute force solution. Ignore the problem space. Sometime usually and square. And optimize. Turns out there might not be a ON solution. I have no idea. I think I asked them about that. This is what I asked. But so after I complete my own solution, okay. Right. So you can go to 2 to the k, but that's a lot, no? So what we did is just loop pairs of words and compare the frequency and find out their frequency. um, check the max length if they do not share common word. Right, so okay. Let's give me time to make exceeded. Cry emoji. Cry emoji. Okay. So when I submit here, right, I have time limit. Oof. My first optimization is I would cache the frequency. Oh, let me edit this. Need to repeat. just go to show that. Guess is one of the important technique. And solution. We should study cache. Okay. Let's just not show this. However, the runtime is horrible. Runtime is 4,000 something. Another weird thing is the runtime above is for when frequency is implemented as midship. Same thing. Same thing is on passing go back to array and it is faster somehow. I do not know how LeetCode I can measure them, but it is interesting to say the least. So the original solution when we do that is this. Because we do what? 88, 899, 4439 divided by 899, like 4% increase, whatever. No complaint. I guess, guys. Got lunch break. You should add the link. Cat lunch break. There we go. Okay. We make it smaller. Okay. No. Oh, I want to go back. Maybe make it smaller. Okay, good. Okay. Okay, so the next thing we look at only file and directly empty calculate wrong path. Oh, okay. Just simple. Stack, expand, and collapse, storing the directory correctly. Select the HK that I did not take into account. One HK that I take into account is if the path has only directory, then I accidentally append an extra slash. We do so like okay. So basically what I fix is you need to calculate if so if the directory is empty, it should not append the path. Oh, I forgot to okay, I did talk about one further. So I guess the thing here is ON. Right. Yeah, ON. And the full code is this is basically keep track of PC because directory span or contract. Right. Hmm. Then we do what do we do? What do we do? Hold on, let me post some Instagram stuff. Okay, then we do this one. Reconstruct. So my original thought is to what do I do here? The original thought that I have is basically find PW in this group. Find all the word and their frequency. But these turns out to not work. Because, for example, 2 and 1 share an O, right? So doing frequency, you can't tell which is which, right? A Twitch user actually suggests or him that. Thank you. Try and see if there is a character that can be unique. Please search and figure out the share digits using fully figure out the digits. What did they say? Hold on. What did they say here? Mute. No, not this one. The most recent one. This one. What they say here. Thank That is very smart. Okay. We can. What is that we can hit? We can find 0. We know this. We can find even number. So like 0, 2, 4, 6, 8 with a digit word. With a digit word that is unique. For example, we can use 0 Z to find 0 because it does not share with any other digit. Okay. To find the odd number, 1, 3, 5, 7, 9, we can use their digit characters with a digit characters. The digit that share with the even one to infer their currents. What is wrong here? For example, we share a H, right? So, for example, like 3 here. Right? 3 share an H with 8. With 8, which we can uniquely find above. Then the sum, the currents of 3 is actually frequency of H, but minus frequency of 8 or frequency H if frequency of 8 is not available, and so on. The 9 one need to be careful because it's shared with, what is 9 shared with here? 5, 6, 8. 5, 6, 8. Okay, so finally the code is here. Whee! Okay. Time complexity is basically ON, right? Because the max operation here is you loop through the word and you get the thing. Right? Submit. Ah, come on. City meat. Come on, bruh. Think time complexities away. Complexity, yes. What, bro? Come on. Give me. Okay, fine. I think so. Finally, we do 3 note. Who's the author of these pictures? Are they the author of these pictures or somebody else? Okay, let's just link it to them. Just self join and count and it fail figuring out the node type. Root is parent is no. Root is parent no. Inner child is not no, and leave child is no. I always have to refer back to this picture caption into this guy. Okay. So enough. Otherwise, enough. All right. Yep. What? They rarely meet you daily. What? So how much did they rate limit you on analyzing code. See? This is a picture. Okay, so that was the code. First one is this one. Second one is Toyota. Writing documentation. Number one use case. Let's just move caption. What? I want to do that caption. Make it smaller. Can't see. We have to take it from, and this is all about the prom. the prompt meme, right? What? Charlie, right? Charlie, it's always sunny. Charlie Day. Does it ruin Charlie Day? Who said trust but verify? Is that Ron Reagan? Trust but verify. Okay. So far so good. We just need 2 things left. Impression ranging from anything the interact with the site, like hover over image, click and watch, pause, let's see. Never want to try more enhanced personalization. Wider range of exposure. The title. A/B testing and placement. Right. Just need to queue the raw event out to what do you call this? Do analytics, learning, to suggest so sort of like this. Right, they have a picture in there. The image, which is linked to desktop. go to see Netflix. I know, I don't care. Is iceberg Apache iceberg like SV glacier? I should look into this. Iceberg. Iceberg. Okay, so that was that. What? Car company. Engine. Is it for historical data storage or later machine learning? Like the infotainment mode case that the current letter in further does not support. Decided to roll the view. Yeah. other engine. Will also have meditation. Okay, so we have the slide. We just get the slide right here. Oh. Link to and we talk about image. What? All right, I think that's it. I think I'm gonna call it. I am going to play 1 hour of game in 10 or 15 minutes, but let's call the stream for now.